Hello everyone, welcome to my video series called Six Sigma in Action, where we cover real life case studies using Minitab. In today's chapter, we'll be looking at process capability analysis. Process capability analysis basically tells us how well a process can produce outputs that meet customer specifications. So we will be using the DMAIC process in this case study as well. So we start with the define phase. This case study is essentially a Six Sigma project aiming to improve the manufacturing process capability of a car part. So the goal here is to improve the manufacturing process for a car part's diameter. The specification limits are provided, and those are the customer's specification limits. Upper specification limit being 60 units, and lower specification limit being 50 units. So the problem statement is increase the process capability by raising CP and CPK values, the process capability indexes, and higher the CP and CPK values, the better it is for the process. And here are some of the formulas for process capability indexes. So the next phase in our DMAIC process is the measure phase. In measure phase, the first thing we do is obviously collect the data. In this case study, we collected 20 samples, each sample containing 5 specific parts, and their diameter was measured. This data was finally uploaded to the Minitab. Next step we need to do in measure phase is check for normality, because when you're trying to find capability indices, the assumption is that data follows normal distribution. So we gotta check that. And after that, we do have to transpose the data that we have loaded into Minitab. We'll get to see this in Minitab, but the reason this is done is because this is a format that is required for the statistical control charts, that is X bar and R chart. The format should be such that each row represents the sample. And then finally, since the sample size for each sample is 5, we can use X bar and R chart. That's what we do next. And after all that is done, after data is loaded, normality is checked, transposed, and statistical control charts are created, then we can go ahead and do our process capability analysis against the customer's provided specification of USL 60 and LSL 50. We'll get to see all of this happen in Minitab next. So here I have loaded the data, those 20 samples, each sample including 5 products. So that values have been added here into Minitab. So the first thing we need to do over this column here is basically the same values all mentioned in one column, and here we have distributed it across 20 samples. So the first thing we need to do here is check for normality. So to check for normality, you go to stats and then basic statistics and normality test. You can include the before variable here, select, and you can write normality test before process improvement and hit OK. So this is what shows up. So since the p-value here is 0.794, which is higher than 0.05, we can say that the data is normal and we can proceed with the rest of the activities. So since the data is normal, the next thing we need to do is basically transpose this data so that we can go ahead and do the control charts. To transpose the data, we gotta go to data and transpose columns. Select all the columns here, and we can call the new worksheet as transposed data, and hit OK. So here a new worksheet was created called transposed data, and so it's basically the same data. It's just mentioned, it's just transposed. So each row refers to one sample, and each of these column refers to one product. So I'll just write P1, P3, P2, P4, P5, representing 5 different types of products. Now, now that we have transposed the data here, we can go ahead and do the control charts. So since the sample size is 5 and less than 10, we can use X bar R chart. We'll start with R chart, see if R chart is in range, if if the data is in statistical control from range point of view. And if it is, then we can also go ahead and do it for the X bar part. So go to stats, control chart, and you could actually do X bar and R together, but for this case study, let's do it separately. So observation for a subgroup are in one row of the column. That's true. And select um, and hit OK. So here's the graph we get, and it seems like it is under statistical control since it has not gone past the statistical upper control limit and lower control limit. But there is definitely some variations here. But since it is in statistical control, let's go and do the same for X bar. Go to stats, control chart, subgroups, X bar. This is going to be the observation for a subgroup are in one row of the column option. Select all the columns and then hit OK. And that basically gives us the statistical control chart for the mean. And even that one seems like at least it's within the statistical control. However, again, good amount of variations in here as well. But since it is in statistical control and earlier we saw that the data is also normal, we can actually go ahead and do the process capability analysis. So process capability analysis will be done on this format of the data. All you gotta do is go to stats, hit quality tools, capability analysis, normal, subgroups, across the row, off, and select all these columns, and the lower spec provided was 50, the upper spec provided is 60, and you can go to options here. You can remove the overall analysis. For title, you can write capability analysis before process improvement. Let's do it. Let's hit OK. And so this is what we get. It basically shows that the CP value is 0.85, the CPK value is 0.79. Since the CP value is greater than the CPK value, the process is a little off center, but there is potential for improvement in this process. And this data over here also gives us some idea about how many parts are out of the specification limits, parts per million. So 20,000 parts per million are observed to be out of the specification limit, and around 12,375 parts are expected to be outside the specification limit with the current state of the manufacturing process. So that's the value we got, CP 0.85 and CPK 0.79. Now there'll be analysis of this data to figure out if there is something that can be improved in the manufacturing process, and we can again do this analysis, this measurement, to see if there has been any improvement in the CP and CPK values. But that's about it for the measure phase. And now we'll move on to the analysis phase. So after the measure phase, we move on to analyze phase. In analyze phase, the production manager along with her team analyzes the process and identifies that a couple of machine tools on the assembly line are not properly aligned. The reason she was able to get to this conclusion was because when we looked at the control chart, X bar and R chart, it revealed some non random variations and also pinpointed variability patterns over time. And when we looked at the process capability analysis, although the process was in control, the CP and CPK values were too low, indicating inconsistent performance. Also, the low CPK hinted that the process was centered too close to one spec limit. This usually happens when there is a potential tool misalignment. This led the team to investigate physical sources, and that's how they found tool misalignment on specific machines. So, next we go to the improve phase. In the analyze phase, we had identified that the couple of machine tools were misaligned. They were realigned in this process in the improve phase, and the process was run again. Now we basically repeat the same measure phase, but with the new data that was collected after the machine tools were realigned. We start by collecting new data. This time we collected 5 samples, each with 12 parts. Their diameters were measured and the data was loaded into Minitab. And next, same as previous, we check for normality because we want to check the capability indices forward, and normal distribution is something that is required for that. We transpose the data as well because we want to run the control charts in Minitab. We transpose the data such that each row represents the sample, which is basically 5 samples, so 5 rows and 12 values. And then we will do the statistical control charts, the X bar. This time we're not doing the R chart, we'll be doing the S chart because the sample size is 12 and which is greater than 10. So an S chart would be better suited. And then finally, we do the capability analysis, process capability analysis for the same spec limit that customer had provided, upper limit of 60 and lower limit of 50. We will be seeing all of this executed in Minitab. Okay, so after the process improvement, here is the data that has been loaded. We had 5 samples collected, each sample containing 12 parts this time. Since we've already done the normality test with the previous data and the data has only gotten better, so we'll assume that the data is already normal and go ahead with transposing this data. To transpose, you go to data, transpose columns, select all the columns, go to new worksheet, call it transposed data, and hit OK. So there we got our transposed data. Uh, one row representing one sample, so 5 samples, each sample containing 12 parts. So I'm just gonna name these. Okay, so 12 parts or 12 products. This one we can call sample. Okay, so now we will be doing the X bar S chart. Let's start with S and see if that's under statistical control. If that is under statistical control, we can move on to do the X bar. To do the control charts, you go to stats, control charts, charts for subgroups, S chart. Again, S chart is being done because the sample size here is about 10. Select all your 12 parts and then hit OK. And this is the graph we got. So looks like it is pretty much under statistical control uh, for standard deviation. So at least since that's the case, we can move on to the next control chart subgroups and for X bar. Same thing for X bar, observation is on one row of the column. Select all your columns and hit OK. This one as well looks like it's under statistical control, has not breached the UCL and LCL. That means that we have the permission to do the process capability analysis. To do the process capability analysis, you have to go to the previous format of the data because that format, remember, it only works for control charts. So go to quality tools, go to capability, go to normal, and it's going to be subgroups across the row of. You select all your items here, and then lower spec is same 50, 60 as upper spec. Options, you can remove the overall analysis. You can call the title as capability analysis after process improvement. Hit OK. Everything looks good. Hit OK again. And let's see. So this is what we got. And a few things to observe here. The sample mean is tighter. The standard deviation is tighter from previous results that we got, previous process capability report. CPK value and CP value are matching and higher than previously what we got. So with that information, we can say that this process is much tighter than what we had previously. And it's also centered because CP and CPK values are matching. Down here, we can see that the parts per million observed out of the spec limit is 0 and expected is around 7200. Previously it was around 12,000. So even there we see some improvement. And so overall we can say that the process has improved, it has become tighter after the alignment or realignment of those two machine tools. So that concludes our improve phase. So now that we've completed the improve phase, the next phase is the control phase. In control phase, with the help of suppliers of the machine and the tools, the production manager installed some sort of fail-safe mechanism that prevents misalignment of the two machine tools. And that should take care of those machine tools from going misaligned. And inadvertently, it should take care of the process as well. Thank you so much for watching. That was it for this chapter. And I'll see you guys in the next one.